If you could time travel back 11,000 years, you'd find yourself in a lush Sahara, filled with green forests, grazing animals, thick foliage, and colourful birds. This was an era when the Sahara was unrecognizable compared to today. Back then, the Sahara wasn't a sea of sand, it was a thriving green paradise. Imagine forests so thick you could barely see the sky, rivers carving their way through the land, and animals like elephants and giraffes roaming freely. Even massive lakes like Lake Megachad covered vast stretches of the region. Archaeologists have found plenty of proof: animal bones scattered beneath the sands, fossils of underwater creatures, and even the remains of ancient human settlements. Picture this: carvings on rocks that show giraffes, cattle, and elephants, animals that belong in lush, green environments. But all of that is gone. Now, what if the lifeless Sahara could transform into the lush wonder it used to be, while also addressing our current needs for crop production, carbon absorption, and renewable energy? Keep watching as we explore the future of the Sahara, a vivid snapshot of a world almost too wild to believe. But to begin, let's establish some important context. The Sahara Desert is the world's largest hot desert, stretching across 9.2 million square kilometers, 3.55 million square miles, in North Africa. To put that into perspective, it's roughly the size of the United States. When people think of deserts, the Sahara is usually the first that comes to mind, with its endless golden sand dunes, scorching heat, and vast, barren landscapes. But there's so much more to it than meets the eye. While the Sahara is famous for its sand dunes, they only make up about 20% of the desert. The rest consists of rocky plateaus, gravel plains, dry valleys, and even some mountainous regions. The highest point, Mount Kusi in Chad, reaches over 3,400 meters, approximately 2.11 miles. These dramatic landscapes make the Sahara incredibly diverse and stunningly beautiful. This desert is home to an array of wildlife that's adapted to survive extreme conditions. You'll find camels, fennec foxes, scorpions, and even migratory birds. There are also ancient human settlements and nomadic tribes like the Tuareg, who've thrived here for centuries with their rich traditions and ingenious ways of living. Speaking of history, the Sahara has seen massive transformations over millions of years. Believe it or not, it wasn't always a desert. So what went wrong? The answer is simpler than you think. It was the sun. As far as environmental shifts on Earth are concerned, the sun has been a consistent villain, and it is always aided by the Earth itself. A scientist, Milankovitch, helped put this in perspective when he discovered that the Earth's orbit around the sun, axial tilt, and wobble changes periodically over tens of thousands of years, and that this change disrupts the weather and seasons. This discovery was important because any slight change in the way sunlight is distributed across Earth immediately affects the weather or vegetative conditions on it. These changes birthed the flourishing forests of the Sahara, but they also took them away. Now, let's break down how that works. Every 100,000 years, the shape of the Earth's orbit changes from being nearly circular to being more elliptical. When it does, the difference between the Sun's distance at perihelion, which is the closest point to the Sun, and aphelion, which is the farthest point, becomes greater. But the exact opposite of this occurred about 10,000 years ago, during the Holocene epoch. During this time, the Earth's orbit became more circular. So the northern hemisphere, which was closest to the Sun, experienced more sunlight. The temperature became quite warm for longer periods, and the warmth encouraged the growth of vegetation across the Sahara. How? The heat on the land created a pressure difference that drew moist air from the Atlantic oceans. More water evaporating from the ocean into the clouds because of the heat meant more rainfall in the Sahara. Plenty of rainfall meant the gathering of running water bodies that spread across the entire land. But that was not the only change. The wobble of the Earth's axis changed too. This wobble controls the timing of the seasons, and it changes approximately every 26,000 years. Well, this change happened to occur at the same time the northern hemisphere was closest to the sun. So solar radiation increased again during the summer months, and this also increased monsoonal rains over the Sahara. Thanks to all these orbital and axial conditions, about 10,000 years ago, the Sahara flourished. Rainfall increased, vegetation grew, and large lakes like Lake Chad expanded. The Sahara became a glowing paradise, and humans also settled on it with their cattle, and they all lived happily. But not for long, the lost forest. Around 5,000 years ago, the villain struck. The Milankovitch cycle shifted yet again. Earth's axial tilt decreased, and the precession cycle shifted, making the summers in the northern hemisphere less intense. With weaker solar radiation, the monsoons that had drenched the Sahara weakened. Rainfall became less frequent and could no longer sustain the forest. So, just like that, desertification began. Plants died and rivers dried up, and erosion took over. Then the dust storms began, and without plants to stabilize the soil, they became more frequent. They spread particles into the atmosphere and suppressed rain again. Gradually, forests became grasslands. In turn, grasslands became an arid desert. All this did not happen immediately. It was a slow, drawn-out process that occurred over several millennia. But by around 5,000 years ago, the transformation was complete. The forest was gone, and the hot, harsh desert we know today was born. Humans made it worse too. Their activities, like overgrazing their cattle and deforestation, sped up the desertification process. And when the land became less fertile, they packed up their villages and migrated to more hospitable regions and stayed away. Hundreds of years later, humans returned to use the Sahara to transport goods on camels in and out of northern Africa. But one day, a large bone was discovered buried in those hot sands. And just like that, archaeologists began to dig, and more bones, fossils, and pollen were found. With these new discoveries, scientists and engineers began to see the potential in that vast land. The dead Sahara could be brought to life again. The forest could be rejuvenated and rebuilt, and hundreds of animals would graze just like they had thousands of years ago. They found out that lost paradise could return. But how? Just a quick pause. If you're enjoying this video, be sure to like it, subscribe, and tap that bell for instant updates. The future of the Sahara. To begin, let's take a short trip into the future of the Sahara with James Duncan as our guide. James Duncan was the first to write down a framework for rejuvenating the Sahara. If the Sahara was irrigated, he thought, the wealth of northern Africa would increase, and Africans would no longer need the white man's ships to export. Agriculture would boom too, and they would no longer need to sell slaves. Duncan's plan was simple, that drought-resistant trees should be planted across the Sahara, which should halt desertification. These trees, he believed, would stabilize the dust, improve soil quality, and even encourage rainfall. It was a good plan, but it failed because there was no modern technology or funding, no advanced irrigation systems to provide water, and no scientific understanding of how ecosystems worked. And of course, his government was not willing to part with the huge sum needed to build technology for this project. His ideas were simply ahead of their time. But not anymore. Technology has grown massively since, and that idea is now being revisited by several top world rulers. It has even developed into full-blown projects with billions of dollars in funding. One of such projects is the Great Wall Project. This Great Wall has nothing to do with China or even bricks, but everything to do with reviving the green of the Sahara. In fact, it has been called one of the most ambitious environmental projects humanity has ever attempted. In the Sahel region of Africa, experts and natives are planting or building a green wall of trees and vegetation that will stretch 8,000 kilometers long and 15 kilometers wide. That's approximately 5,000 miles in length and 9.3 miles in width. Already, many top governments have donated billions of dollars to help it succeed. This wall will cut across Africa from Senegal in the west to Djibouti in the east. It all began in 2007. That year, about 20 African leaders decided they had had enough. The Sahara Desert was spreading its tentacles into their countries and drying up their land. So they sat together in the African Union and decided to address desertification once and for all. What did they decide? They decided to plant trees from Senegal to Djibouti. But how does that help the Sahara? Just like James said, trees increase soil quality and hold down moisture. So experts and local farmers, men and women, went on foot down to the edge of the Sahara, all around the continent, and began digging. They dug holes in the ground and planted seeds in them. Then they made sure to feed these holes with water morning and night. What happened? Slowly, these dry stretches of land began to have green patches. Pictures and videos from around the continent have shown that these patches of green have begun growing and spreading annually. Soon, they would completely cover the land, revive the soil, and create habitats again. In countries like Senegal, nearly 12 million drought-resistant trees have been planted, and in Ethiopia, over 15 million hectares of degraded land beside the Sahara is back to life. It is hard work, but they are not slowing down. It has been over a decade since the first saplings were planted, and the results are great. And what is more, this technique does not seem to have any future risks. How much havoc can tree planting cause? It is a harmless project that just might force the hand of the Sahara and restructure its nature. Many scientists have even predicted a massive change in the Sahara by 2030, just by this project alone. It is no wonder it has attracted so much global attention from international organisations, NGOs, and private investors who are interested in changing the Sahara. The UN Convention to Combat Desertification, for example, and the World Bank's Sahel Initiative have pumped billions of dollars into the GGW to help restore 100 million hectares of Sahara land by 2030. Imagine the dry Sahara becoming a large, fertile land with green vegetation again. But just as these 20 countries are encroaching into the Sahara from its edge, Egypt is taking a whole different route with its plans. They have set up a major project, which everyone calls Egypt's New Delta Mega Project. Egypt has been very aggressive with its plans for the Sahara. Their population is blowing up, and birth restrictions haven't helped at all. They need new land, and it seems they have decided the Sahara is what they need. This project is Egypt's way of expanding into the desert. But how will they do this? By building the largest artificial river in the world. According to written plans, this river is supposed to transform more than 9,000 square kilometers, 3,475 square miles, of desert into fertile farmland. And this is how they plan to do it. The Nile River extends to Rosetta, and Egypt intends to build its artificial river by diverting its water into the man-made bed they plan on digging. This diversion is supposed to cause the water to travel 50 kilometers, approximately 31 miles, along the Mediterranean coast before turning inland and running through underground pipes all the way into the Al Hammam treatment plant. While that is happening, another part of the Nile will be directed upstream to arrive at the same destination. If they succeed, they will reclaim over 2.2 million acres of the desert. This is the second most ambitious project after the Green Wall project. And it just might work. With this flowing water, they would turn the desert into a flourishing agricultural city and expand their country. Many experts think this project has a high chance of success, especially since this is not Egypt's first rodeo. In the 1990s, Egypt launched the Toshka project to cultivate the Western Desert using Nile water. But it failed, so they launched the Al Salam Canal project to reclaim Sinai land for agriculture. With concrete experience, they do not plan to fail this time. In fact, when you read through the plans they have set up to achieve this, you will respect how much planning has gone into this. They have even replaced expensive technical systems with cheaper alternatives. Apart from diverting the Nile, they plan on irrigating many parts of the desert, but they plan to use recycled wastewater. They have also decided to use seawater and have plans to open up desalination plants that would convert the seawater into fresh water for use. But where many experts and scientists are raising alarm is in their plan to extract groundwater to add to the water flow, and we will address why a little later. To power the project, Egypt does not plan on using expensive electricity generators. Instead, they are building solar farms and wind turbines. They also plan on introducing mechanized farming practices and to cultivate only high-value crops that are suitable for Egypt's climate. Crops like wheat, corn, and vegetables. They have already spent billions on this project to wet and irrigate the Sahara, and efforts are already being made to build the artificial riverbed. Imagine all of that water being soaked into the hot sands of the Sahara day and night for months, in addition to the artificial river running amok from the River Nile. Then, when the sun beats down on this moisture and absorbs the droplets, they fall down as rain. Scientists speculate that if that happens, soon a tiny grass will shoot out, and then another and another. And just like that, the Sahara will go from brown to green. Egypt will single-handedly change nature, and other countries will scramble to irrigate and claim land in the desert too. If they do, the Sahara we know now would only be seen in textbooks. But while this change will be such a beautiful development, it might birth future problems. Experts have speculated a depletion in ocean life. The Sahara is an important part of the ocean's ecosystem because the base of the ocean food chain is phytoplankton, which is formed from nitrogen, phosphorus, and trace amounts of iron. Nitrogen and phosphorus are available in the ocean, but iron isn't. Where does the ocean get iron from? From dust blown from the Sahara into the Atlantic Ocean. This dust carries with it enough iron to give the phytoplankton a boost to grow in large masses. In turn, phytoplankton adds oxygen to the water. A large part of the ecosystem in the Atlantic survives from the wind-blown dust off of the Sahara sands. So, if the Sahara becomes a paradise and is covered in trees, the dust will die off, hurting sea life. There is also a deep fear from experts that saving the Sahara might deplete water sources from major rivers and from underground. If the water in this place drops in supply, humans will be in a major disaster. Then there is also the issue of carbon emissions. The processes involved in transforming a desert into a forest, like land clearing and soil disturbance, might release more carbon than is needed in the long run, especially if not managed properly. However, research is currently ongoing to find easy solutions to these problems. Many researchers have even suggested that factory-made waters replace underground water. All that is left is solutions to carbon emissions, then work on the Sahara will explode on a grander scale. If that happens, we will experience a Sahara with birds, animals, and green trees. But even if all human plans fail, according to predictions by scientists, in about 10,000 to 15,000 years, the Earth's axial tilt and orbital precession will align again, and summer monsoons will again increase in the northern hemisphere. When this happens, rainfall would return to the Sahara, and the lost forest would be found. But there is a twist. There is no proof humans will still exist to witness that change. I guess inducing that change is a better option then. How can there be a flood in one of the biggest deserts in the world? Well, you are in for a surprise. Torrential rains transformed parts of the Sahara, creating temporary lakes and rivers in a region defined by its dryness. This stunning occurrence not only captured global attention, but also raised critical questions about climate dynamics and the increasing role of extreme weather in reshaping iconic landscapes. To understand how and why such an anomaly happened, let's explore the science behind the flooding, its impacts on ecosystems and communities, and the broader implications for our changing planet. What exactly happened? What does it take for one of the driest places on Earth to turn into a watery spectacle? In August 2024, a perfect storm of atmospheric and climatic factors converged to bring torrential rains to the Sahara Desert. Imagine regions accustomed to receiving a mere trickle of rain suddenly inundated with enough water to fill rivers and create temporary lakes. This was no ordinary weather event, it was a dramatic meteorological anomaly. According to NASA's Global Precipitation Measurement (GPM) mission, a series of atmospheric anomalies in August 2024 caused an exceptional downpour in the northern and central Sahara. These rains, described as intense and widespread, were a result of moisture-laden air masses moving unusually far north due to shifting weather patterns. Satellite imagery captured the stunning transformation of the desert, with temporary water bodies forming in regions that haven't seen significant rainfall in decades. News coverage highlighted the event's sheer scale, reporting that some areas received over 100 millimeters, nearly 4 inches of rain in less than 48 hours. To put this into perspective, the Sahara typically receives less than 25 millimeters, 1 inch of rain annually. This deluge was not just a drizzle, it was a full-scale downpour that overwhelmed the desert's sandy soil, which is ill-equipped to absorb water quickly. The science behind the floods. The flooding of the Sahara Desert in 2024 was a result of a complex and fascinating interplay of atmospheric and climatic factors. One of the most significant contributors was an atmospheric river, a narrow but powerful corridor of concentrated water vapour in the atmosphere. Often referred to as rivers in the sky, these atmospheric rivers can transport vast amounts of moisture from tropical regions to other parts of the globe. In this case, an atmospheric river carried moisture-laden air far into northern Africa. As this humid air mass reached the Sahara's cooler and drier atmosphere, the moisture condensed, leading to heavy and sustained rainfall. Another critical factor was the unusual behaviour of the jet streams, which are fast-moving air currents in the upper atmosphere. Jet streams usually act as barriers that confine weather systems to specific regions, but during this period, the jet streams shifted southward. This shift allowed warm, tropical air filled with moisture to penetrate deeper into the desert. This convergence of tropical air and cooler desert conditions created the ideal environment for an intense and prolonged downpour. Warming oceans added yet another dimension to the equation. Rising sea surface temperatures in both the Atlantic Ocean and the Mediterranean Sea have increased the rate of evaporation, pumping more moisture into the atmosphere. This amplified the intensity of the atmospheric river, effectively supercharging the rains that fell over the Sahara. The connection between ocean temperatures and atmospheric moisture is a well-documented phenomenon, and in this case, it played a pivotal role in the scale of the flooding. Lastly, climate change has likely influenced the occurrence of such extreme weather events. While it's difficult to attribute any single event solely to global warming, the overall trends of rising global temperatures are disrupting established weather patterns. Climate change has been linked to more frequent and severe anomalies, including shifts in jet streams, enhanced atmospheric rivers, and extreme precipitation events. The Sahara floods serve as a reminder that the impacts of climate change are not confined to coastal regions or polar ice caps. Even the world's most arid deserts are not immune to its effects. Impacts of the flooding. Ecological transformation. The sudden and intense rains brought a temporary revival to the Sahara's otherwise barren ecosystem. Dormant seeds, which had lain in the sand for years, began to sprout into lush greenery almost overnight. This transformation turned parts of the desert into unexpected patches of life, complete with blooming plants and grasses that provided food and shelter for small animals. The pools of water created by the floods acted as oases, attracting migratory birds and other wildlife. Species that rely on wet habitats, such as amphibians and insects, appeared in these areas, adding to the diversity of the ecosystem. However, this revival was short-lived, as most of the water quickly evaporated or was absorbed into the ground, leaving behind an altered landscape. Despite its fleeting benefits, the deluge posed significant challenges. The force of the water caused soil erosion, washing away layers of sand and exposing rock formations. Additionally, flora and fauna that had adapted to the desert's arid conditions faced disruptions. Some plants, for instance, were overwhelmed by the sudden water, leading to localized die-offs. Such events highlight the delicate balance of desert ecosystems and their vulnerability to sudden changes. 2. Human communities. For the human populations living on the edges of the Sahara, the floods brought mixed fortunes. In many cases, the rains replenished aquifers and wells, providing much-needed water for drinking and irrigation. Farmers saw an opportunity to cultivate crops in areas that had been too dry for agriculture, and herders welcomed the temporary increase in grazing land for their livestock. However, the floods also brought destruction. In some regions, the sheer volume of water overwhelmed infrastructure. Roads were washed out, homes were damaged, and essential supplies were delayed or cut off. Villages in low-lying areas bore the brunt of the damage, with some families losing their homes and possessions. CNN's interviews with local residents captured the complexity of their experience. One farmer described the rains as a blessing and a curse, a moment of hope for the future, but also a source of immediate hardship. Relief efforts were hindered by the remoteness of the affected areas, leaving many to rely on their own resilience and community networks to recover. 3. Geomorphological changes. The Sahara's landscape has been shaped over thousands of years by wind and occasional rainfall, but the 2024 floods introduced rapid and dramatic changes. Temporary rivers, called ephemeral streams, carved deep channels into the sand, redirecting the flow of water and creating new pathways. In some places, the erosion was so severe that it exposed ancient sedimentary layers, offering scientists a glimpse into the geological history of the region. The formation of temporary lakes also altered the terrain. These water bodies, though short-lived, left behind mineral deposits as they dried up. Such changes can have long-term effects on the desert surface, influencing wind patterns and the movement of sand dunes. In the aftermath of the floods, researchers observed changes in dune formations, with some areas appearing more stabilized due to the moisture content in the sand. These geomorphological changes are not just a curiosity, they also have practical implications. Altered landscapes can affect navigation and land use for both humans and animals. For instance, newly formed channels and lakes may serve as natural barriers, forcing communities and wildlife to adapt to the new geography. The 2024 floods offer valuable insights into the Sahara's ancient climate history. Thousands of years ago, the region was a lush savanna with abundant water bodies. Events like this remind us that the Sahara's current state as a desert is not a permanent fixture, but a phase in its long climatic journey. Moreover, the floods serve as a stark warning about the unpredictability of a warming planet. As global temperatures rise, extreme weather events are becoming more common, even in areas traditionally considered stable. The Sahara floods highlight the interconnectedness of climatic systems and the urgent need for global action to mitigate the effects of climate change. This event provides an unparalleled opportunity for scientific research. Studying the desert's response to such a sudden and intense influx of water can improve climate models and enhance our understanding of how ecosystems adapt to rapid environmental changes. These lessons could prove invaluable as we prepare for a future where such extremes may no longer be rare. The 2024 Sahara floods were a powerful reminder of nature's unpredictability and the profound interconnectedness of our planet's systems. This rare event transformed one of the world's most iconic deserts into a fleeting oasis, offering both awe-inspiring beauty and sobering lessons. While the floods temporarily relieved people and ecosystems, they also underscored the vulnerabilities of our changing climate. As the Sahara returns to its familiar arid state, the memory of its brief encounter with water lingers as a testament to the ever-changing nature of our world. It is a call to action to better understand, protect, and adapt to the forces shaping our planet. The Sahara's story of resilience and transformation reminds us of the delicate balance between survival and change in the face of nature's immense power.
As astonishing as it was, the Sahara surprise flood was not an isolated fluke. Other famous deserts have experienced similar rare and dramatic flooding in recent years. Take the Atacama Desert in Chile, often called the driest place on Earth. In 2015, the unthinkable happened in the Atacama as well. Dark storm clouds gathered over northern Chile's desert mountains in late March of that year. Normally that area might not see any rain for decades, but over a couple of days, those clouds unleashed a year's worth of rainfall or more. By most standards, the totals were modest, a few dozen millimeters, but in the Atacama, it was enough to cause chaos. Dry riverbeds that hadn't seen water in ages turned into raging mud flows. Towns like Chañaral and Copiapó were hit hard as floods tore through streets and homes. By the time the skies cleared, at least 24 people were dead and thousands of dwellings were destroyed or damaged. It was the region's worst flood in almost a century. Some places even recorded their first measurable rain in living memory. The parched soil couldn't absorb the sudden downpour, so water raced downhill, carving new gullies in the desert. Yet, in the aftermath, the Atacama offered a poignant sight. Weeks later, dormant seeds sprouted and the desert floor burst into a carpet of purple and pink wildflowers. It was a brief, beautiful bloom that hinted at the life hidden in the desert, even as residents were left cleaning up an ocean of mud. North America's deserts have seen floods too. Death Valley in the Mojave Desert, famously one of the hottest, driest spots on the planet, was slammed by an unprecedented flash flood in August 2022. Monsoonal storms dumped about a year's worth of rain, over 1.5 inches, in just a few hours. Tourists watched as a wall of water and debris came roaring through the canyons and across roads. Cars were engulfed by mud and rocks, and every road in the national park was washed out or buried. It was described as a once-in-a-thousand-year rain event for that valley. Shockingly, a year later in 2023, the desert was deluged again when the remnants of a Pacific hurricane swept inland. These back-to-back floods left park rangers astonished. 2 extreme floods in 2 years. In a place that typically gets barely a couple of inches of rain in an entire year. The damage was extensive. Pavement buckled, buildings were swamped with silt, and Death Valley had to close for weeks. It was a stark illustration of how quickly conditions can slip from extreme dryness to overwhelming water. Even the Gobi Desert in Asia has felt the effects of uncommon floods. The Gobi, which spans parts of Mongolia and China, is a cold, windswept desert where rain is scant and usually light. In the summer of 2018, parts of the Gobi saw sustained heavy rains that locals hadn't witnessed in decades. Nomadic herders in Mongolia's Gobi region found their yurt camps besieged by sudden streams. Dirt roads became impassable muddy bogs. In some areas, floodwaters washed out sections of the single railroad line that crosses the desert, disrupting travel and trade. Small villages, which had virtually no drainage infrastructure, were suddenly inundated. Livestock and camels, so crucial to families' livelihoods, were swept away or later died from exposure when grazing lands turned into swamps. For a desert used to drought, too much rain proved just as challenging as too little. People were awed to see rain falling at all, even as they struggled with the damage it left behind. What is causing these deserts, places defined by dryness, to suddenly get drenched? Each of these floods had its own immediate trigger in the weather. In the Sahara, a large storm system drifted unusually far south, effectively an atmospheric river of moisture that dumped torrents over the sand. In Chile, a rare warm Pacific weather system pushed moisture over the Andes, turning what normally would fall as snow in the mountains into rain on the desert below. In Death Valley, an intense summer monsoon storm and later a tropical storm's remnants parked overhead and unloaded torrents onto the desert floor. And in Mongolia, a kink in the jet stream allowed a series of rainstorms to soak the Gobi. In short, an array of freak weather conditions set the stage for each flood. An extratropical cyclone here, a cut-off low there, a stray hurricane elsewhere. These weather systems wandered into places they seldom go, and with them came an unexpected deluge. In each case, the normally sun-baked ground could not absorb water fast enough, so the rain turned into instant runoff, raging over land as flash floods. Beyond the immediate weather triggers, there is a bigger picture. Our climate is shifting, and that can intensify such extreme events. As the planet warms, the atmosphere holds more moisture, which means when it rains, it can rain harder. In effect, a warmer climate loads the dice for heavy rainfall. It can also disrupt the usual patterns of atmospheric circulation, making the jet stream and storm tracks more erratic. The year 2015, when the Atacama flooded, coincided with a strong El Niño, a Pacific Ocean cycle that tends to bring wetter weather to Chile. And overall, rising global temperatures have been linked to more unpredictable rainfall patterns. Scientists note that as temperatures rise, the world is facing both harsher droughts and heavier downpours. In other words, we get either too little or too much water. In simple terms, the hydrological cycle is becoming unbalanced. So while deserts might mostly get drier with global warming, they may also occasionally experience these freak deluges when conditions align. All of this raises a big question. Are these desert floods red flags of an accelerating climate crisis? Many scientists believe they are. Events that were once nearly unimaginable are happening in front of our eyes. They vividly illustrate that no place on Earth is truly immune to the effects of a changing climate. Not even the vast dry expanses of the Sahara, Atacama, or Death Valley. This doesn't mean deserts are turning into wetlands, of course, but it does mean the weather rulebook is being rewritten. What was once impossible can no longer be completely ruled out. Looking ahead, scientists warn that such extreme events may become more frequent in a warming world, raising the stakes for our response to climate change. There are practical lessons to be learned from these surprising floods. One is that communities in even the driest regions need to prepare for the unexpected. City planners and engineers might consider flood defenses or better drainage in desert towns. Unlikely as that sounds, because the cost of being caught unprepared even once can be devastating. For instance, building sturdier roads, better drainage, or small dams to channel flash floods could protect communities when a freak storm hits. And if properly managed, even a sudden flood can be turned to some advantage. For example, filling up empty reservoirs or recharging groundwater to help ease the next drought. Another lesson is the importance of global action on climate change. Each of these floods is like a message from nature that things are shifting. Reducing greenhouse gas emissions won't stop rain from falling, but it can help limit the warming that is supercharging the atmosphere with energy and moisture. Finally, there's a mixed sense of wonder and warning in these events. The image of palm trees reflected in a new Saharan lake or wildflowers blooming across Death Valley is almost magical. Shimmering oases appearing overnight as a reminder of nature's resilience and its capacity for surprise. But it's also an unsettling preview of a future with a destabilized climate. Deserts flooding are like a plot twist in a story we thought we knew. They remind us that we're entering a new chapter where the past isn't always a reliable guide to the future. In the end, the deserts have delivered a clear message in the form of water where it doesn't belong. If these floods are nature's red flags, it's up to us to heed the warning, so that such thrilling anomalies remain rare exceptions and not the new normal.